All right, everybody, welcome to the video here for lesson number 4's homework assignment. So in lesson 4, we kind of took what we knew about solutions to an equation and we applied it now to these complex solutions, right? These imaginary solutions. So number 1 says use the discriminant to predict the number of solutions for the equation below. Discriminant, remember, is just the b squared minus 4ac part of the quadratic formula. So if I evaluate the discriminant here, I'm going to get negative 4 squared minus 4 times 5 times 3. And that value is going to become negative 44. Since the value of the discriminant is negative, that means I have 2 complex solutions. If I was to graph this, it would have no x-intercepts. Right? Those are 2 things I know right from knowing that number. So number 2 asks us to actually solve this equation. Since I've already evaluated the discriminant by plugging into the quadratic formula, it should be a little bit easier. I already know this number. The denominator should be 2 times 5, which is 10. Now I want to simplify this. The square root of negative 44 can be rewritten as I square root of positive 44. And then 44 can be broken down to 4 times 11, so that becomes 2I square roots of 11. I like to do that off to the side so I'm not kind of jumbling up what I'm doing here in the quadratic formula. So now I can say, all right, let's rewrite this as 2 fractions, 4 tenths plus or minus 2I square root of 11 over 10. I'm just breaking apart that denominator into the 2 fractions that it really is. And then I can simplify. 4 tenths is really the fraction 2/5. 2 divided by 10 is 1/5, so I have 1I square root of 11 over 5. That's an I. So essentially what I'm asking you now to do a quadratic formula question, you should probably figure out what the discriminant is first. It usually helps. So for number 3, it's not in the right form. I want to be equal to 0, so I'm going to do that first by adding the 9 to both sides. If I do the discriminant, the discriminant for this one becomes negative 8. That tells me I should have 2 complex solutions. So I have x is equal to negative 8 plus or minus the square root of negative 8, all divided by 4. 2 times 2 is 4. The square root of negative 8 can be I square roots of 8, and then the square root of 8 becomes 4 times 2, so we wind up getting 2I square roots of 2. So when I break this apart, I get negative 8/4 plus or minus 2I square roots of 2 over 4. And I want to try and simplify each fraction. Sometimes they can simplify differently. That's why we separate them. So I have negative 2 plus or minus. This is going to reduce to a half. So I have I squared root of 2 over 2. All right, I'm just reducing the real numbers on the outside. For the next one, also not in the right form. So I want to rewrite it. 3x squared minus x plus 1 equals 0. I'm doing that just by subtracting the x to the other side. If I evaluate the discriminant, I'm going to have negative 1 squared minus 4 times 3 times 1, which gives me negative 11. Negative means there's 2 answers. There's going to be an I in my answer. I know all of that just by finding that value. So I have 1 plus or minus the square root of negative 11 all over 2 times 3, which is 6. Square root of 11 doesn't simplify, right? So the square root of negative 11 is just going to become I square roots of 11. There's nothing else I can do there. So when I separate this, I'm going to get 1 over 6 plus or minus I squared of 11 over 6. Even though nothing reduces, we still want to show it as 2 separate pieces, A plus BI form, right? 2 answers there, and we are good. Hopefully this video helped, and I will see you all soon.